students, welcome back. So as I told you that we will be learning about one more method for finding square root, and this is that method. So next method is finding square root by division method. Now this division method is also known as long division method. So what is this method? What are the steps for finding square root by this method, that is division method? Now to find the square root of 521, say for an example, we have this number 529 and we need to find the square root of this 529 by division method. How do we proceed? Our step 1 is placing a bar over every pair of digits starting from the digit at ones place. So it is like if we have 529 for here, what are we going to do? We are going to place a bar. We are going to just place a bar on every digit starting from the digit at ones place. So here in pair, place a bar over every pair. So this is our first pair. And here we don't have other pair but only single number. So our second bar will be placed here. This is what happens in case of if the digits are odd in number. Just like this. Here we have only 3 digits. So first pair and the second will not be in pair but a bar will be placed over it. Now what is the second step? Find the largest number whose square is less than or equal to the number under the extreme left bar. So we start with the extreme left bar number and that is 5 in this case. So for 5, what will we be writing? We will write such a number that will be the largest number whose square is either less than this number, that is 5, or either equal to 5. So what is that number? That number, if we think, is actually 2. Why is it 2? Because we know that the square of 2 is 4 and that is less than 5. Not equal to 5 but less than 5, because then the next number will be 3 and that square 3 square is 9. That will be larger. But we don't need a number larger than this. We need less than or equal to this number. Take this number as a divisor and the quotient with the number under the extreme left bar. So the quotient will be 2 and it will be written over this extreme left bar. So 2, and here we'll write 2 as divisor, 2 as quotient, divide and get the remainder. So what are we getting? We are getting 1. What's our next step? Now next step is bring down the number under the next bar. What was written here? I'll write again. It's 529. These were the pairs. Here the second bar we wrote 2 here, 4, and when subtracted it got 1. Now bring down the number under the next bar, that is 29. We are going to now bring this whole number, that is 29, here and make it the new dividend. So new dividend is 129 now. Double the quotient and enter it with a blank on its right. So now we are going to divide this 129. For dividing this 129, we are going to double the quotient. So the double of 2 will be 4. And enter it with a blank on its right. I have written it here. Now repeat the same process of step 2 until we get the remainder to be 0 and all the digits in the given number are used. Then the quotient will be the square root of that number. So now think of a number that here I'll write a blank. So just say we have 43. Then 43 into 3 will be 3, 3, 9 and 3 goes are 12. Yes, we are getting 129. So what are we going to write here? 3. If we are writing 3 here, we will be writing 3 here. We get 129. When we divide, we get remainder as 0. So what is the square root? The quotient. Our quotient becomes our square root. So we can say that by this long division method, we have found out the square root of 529 and it is 23. This 23. This is how you use this method in order to find the square roots. Now comes estimating the number. We use bars to find the number of digits in the square root of a perfect square number. Like for 529, how many bars were there? I told you that there will be 2 bars. Therefore, there will be 2 digits. 2 digits were in its square root, and this is what we saw from here. Since its square root was 23 and 23 has how many digits? 2. Therefore, we can easily estimate the number of digits in the square root of a perfect square number by finding the number of bars. So here there were 2 bars, therefore 2 digits in its square root, and here will be how many bars starting from here, then here and this. 3 bars, that means 3 digits in the square root of this number. Now what's next? Next is without calculating the square roots, find the number of digits in the square root of the following numbers. So just like the previous method, finding the number of bars gives us the number of digits in the square root. I'll do the first part for you, do the other part yourself in order to practice more. So this is how many bars will be here? We have 3 bars. Therefore, its square root will have 3 digits. Similarly, do these two parts. Now we are going to find the square root of, first of all, 729 and then 1296. And in both of these we are going to use the long division method or the division method. I'll do the first part for you, just the same steps. 729, what was our first step? Writing the bars. Here, placing the bars. 729. Now we have this. What is this number? This is 7. Now think of a number that has whose square is less than or equal to 7. So there is this 2, and now it's again 2. 2 square is 4. We get 3, and again place this whole number, bring it down, 329. Square this now, square your quotient. Second step was squaring the quotient. We get 4. We need to fill this blank. So what if we multiply, if we multiply 46 with 6, what are we going to get? 6 6 36, 6 12 24, and 6 2 76. No, it's less than. Let's try the next digit, that is 47. Now 47 into 7 will be 7 7 49, 7 7 28, and 3 29. This is exactly the same. So what will be the digit here? 7. So if 7 is here, 7 will be written here, and we get 329. After subtracting it, we get 0. When we get 0, then what will be the square root? This quotient becomes our square root. That is, we can say that the square root of this number 729 is 27. How did we find it? We found it out by using the method of long division. Now similarly, do all these steps, repeat all these steps for finding the square root of 1296. Next example is a statement question. It's written that find the least number that must be subtracted from 5607 so as to get a perfect square. And the second part is also find the square root of the perfect square. So first of all, for this number, we have to find the least number that is to be subtracted from this 5607 number in order to get a perfect square. So that means this is not a perfect square. We need to subtract a number, and that should be the least number from this in order to get a perfect square. So for such questions, we use the method of long division. Again, 5607, place the bars, we get this. And now which number will be written? Whose square is either 56 or less than 56. So that is, brainstorm, that is 7. Because 7 sevens are 49. Here we get 7. Now bring these two numbers down, is 707. Now square this number, we are going to divide this. Now squaring this quotient, we get 14. We need to find the digit that will fill this blank. Now what if we multiply 143 with 3? We get 3 3s are 9, 3 4s are 12, 3 1s are 3, 4 429. No, it's less than. Let's try the next digit, that is 144 into 4. 4 4s are 16, 4 4s are 16, 17. And 4 1s are 4, 5, it's still less. Let's try we can try some other number, the next number, that is 145 into 5. 5 5s are 25, 5 4s are 20, 22, 5 1s are 5, 6 7, 25. So it's now bigger than 707. 725 is bigger than 707, so we cannot write 5 here. We will be choosing the number less than it, that was 4. We will write 4 here, 4 will be placed here again. What are we getting? 576. Subtracting this, we get 6, 10, 3, and we get 131. The remainder, since this number 5607 was not a perfect square, therefore we are not getting the remainder as 0. We are getting the remainder as 131. And this is actually the least number that when subtracted from 5607 gives us a perfect square. So what is that least number? That least number will be our remainder, that is 131. And what is the number that we get when we subtract 131 from 5607? So 5607 minus 13 from 5607, subtract 131. What do you get? You get 5476. So the perfect square is, the perfect square that was less than this number given to us, that is 5607, is 5476. This is a perfect square. Now, so since this was the perfect square, what does our second part need? It is asking us to find the square root of this perfect square. So for the square root of 5476, we can actually say that this 74, since it is not the perfect square of 5607 because the remainder is not coming to be 0, but when we are subtracting 131 from this number, the number we are getting, this quotient is going to be the square root of that number. It always is true for such a situation. So we can directly say that the square root of 5476 is going to be 74. That was coming to be our remainder, or quotient, I mean. 5476, its square root is 74. So what is the square root of that perfect square? That perfect square was 5476 and its square root is 74. You can check this out by multiplying 74 with 74. You will be getting 5476 as your answer. This is how you need to solve these questions. What is our next example? Example number 11 says that find the greatest 4-digit number which is a perfect square. So we need to find the greatest 4-digit number that is also a perfect square. So what is the greatest 4-digit number in general? It is 9999. We know that 999,999 is the greatest 4-digit number. Use the long division method. Place the bars. For 99, we will get 9. We know that 9 9s are 81. Square of 9 is 81. Square of 10 will be 100. That will be greater than it. It will be 18. Bringing these two numbers down, we get 1899. Square of 9 is 18. We need to find one number here. Let's do 188 into 8. What do we get? 8 8s are 64. 8 8s are 64. And 78 ones are 8, 1504. It's less than this. Let's try the other number. 189 into 9 is going to be 9. 9 into 9 is 81. 9 is 72. 80. 9 is a 9. And 9 ones are 9 and 8. 1701. It's still less than this. But next we cannot do because after 9, this will be the greatest number that we can put here. Because after this, we cannot put 10. We only need to put one digit here. So it will be 9 in this case. And 189, here it will also be 9. Now 189 into 9 was coming to be 1701. Subtracting this, we get 9. Here it is 198. What are we getting? 198. Find the greatest 4-digit number which is a perfect square. Again, now just see this previous example. If we subtract this 198 from this number, this is our remainder. We are not getting 0 as the remainder because this 9999 is not a perfect square. But what if we subtract this from here, this number? If we subtract 198 from 9999, subtract 198 from this number, what will be the answer? 19801. And this 9801 will actually be a perfect square because then the remainder will be 0. We just need to subtract this remainder that was not 0 from our number that was 9999, and the answer we get is 9801, which will be a perfect square. And from the previous example, as I told you, what will be the square root? This is, I'm doing some extra part here. This is not asked in this question. The square root of 9801 will be 99, the quotient here. So this is the number, greatest 4-digit number that is also perfect square, that is 9801, and its square root is 99. This is how you do these questions. We have one more example. It's written that in example number 12, it's written that find the least number that must be added to 1300. That is, we need to add the least number to 1300 in order to get a perfect square. We're not going to subtract any number now, but we need to find the least number that when added to 1300 gives us a perfect square. Also find the square root for that perfect square. Number is 1300. Use long division method, place the bars, use long division method, we get 3 3s are 9, 4 4s are 16, no, here it will be 3. 9, it comes to be 4, double 0 is 400, double 3, 3's double is 6, what number will be here, that is what we have to find. What if I do 65 into 5, I get 5 5s are 25, 5 6s are 30. 32, 325 less than the exact. I can try the next one. 6 6 are 36, 6 6 are 36, 396 still less than this one. But 67 into 7 gives us 7 7 are 49, 7 6 are 42, and 4 469. It's greater than this, so I'll choose this digit 6 here. If I'm writing 6 here, 6 will go to the quotient as well. It's 396. We get the answer as 4. Now our remainder is 4. Our quotient is 36, remainder is 4 and not 0 because 1300, that is 1300, is not a perfect square, therefore remainder is not 0. But now we need to add some number, therefore this remainder cannot be such number. Then what will be that number? Now see, this actually shows us that the square of 36, that is 36 square, will be less than 1300. It will be less than 1300 because there is some remainder as well. Therefore, what will be that number whose square will be greater than 1300? That number will be 37 because after 36, the next natural number is 37. Therefore, this calculation shows us that the 37 square will be greater than 1300 and 36 square is less than 1300. So, 1300 actually lies between the square of 36 and 37. Let's find the square of 37. What is the square of 37? 37 into 37. Solve it. 7 7s are 49. 7 3s are 21. 25. 3 7s are 21. 3 3s are 9. 10, 11, 9, 6, 3, 1. 1369. So 37 square is 1369. 1369 minus 1300 is 69. So that shows us what can we conclude from here. This is a perfect square. 1300 was not a perfect square, but 1369 is a perfect square because it is the square of 37. So what is that least number? Subtract 1300 from 1369. That number is 69. This is the least number that we need to add to 1300 in order to get a perfect square, and that square is 1000. Perfect square is 1369. Now, what is the second part is, what is the square root of the perfect square? So, the perfect square was 1369. We know its square root is 37. So, for the answer of this, that perfect square, since it was 1369, we know its square root is 37. This is the way of solving such questions. So, this was all that I taught you in this video lecture. We are done with this video lecture. In the next video lecture, we are going to find the square roots of not regular usual numbers but now decimals. This we will learn in the next video lecture. We'll meet in the next video. Bye bye. Take care.